we're going to look at fractional exponents, which are also called rational exponents. Right? So these are the same thing, just two different names. Fractional exponents, rational exponents, that just means that you have exponents that are fractions. All right, so let's try to look and think about what this might mean. What would it mean if I had 9 to the 1/2 power? All right, so I'm going to tell you what that means first, and then we'll talk about why. All right, so this actually is the same thing as saying the second root of 9, right, or which is, we commonly call that just the square root of 9. Right? So this is actually equal to 3. Okay, so 9 to the 1/2, that's the same thing as the square root of 9, which is 3. So let's kind of think about why that's true. Right? Well, first of all, let's talk about why is the square root of 9 3? Right? Well, in one way of thinking about that is that 3 times 3 is 9. But you can also think about this as the square root of 9 is the same thing as the square root of 3 times 3. Right? And by definition, right, when I have the square root of 3 times the square root of 3, that's just equal to 3. Right? So if I was doing 9 to the 1/2 power, right, well, another way to write that would be 3 times 3 to the 1/2 power. Right? So 9 to the 1/2 is the same thing as 3 times 3 to the 1/2. Right? And then think about what this might mean. This means that I want 1/2 of the factors here. Right? Well, if you look at this, I have 2 factors of 3 here. Right? And what I want is just half of those. So half of those, I just want one of those 3. Right? So that would just be 3. Right? So 9 to the 1/2, I just want 1/2 of these 3's. Half of those, that's just one of them. Right? So 9 to the 1/2, square root of 9, which is 3. Okay? So next one, 16 to the 1/2. All that means is that's the same thing as saying the square root of 16. Okay? So this is the square root of, well, 16 we know is 4 times 4. I just want half of those factors. So 1/2 of those, that's just one of those. So that would just be 4. Okay? Similarly, if I had 8 to the 1/3 power, right, what is that going to mean? That's going to mean the cube root of 8. Right? And we know the cube root of 8 is 2. Right? Why is that? Right? Well, let's write this out. Right? So we know that 8 is the same thing as 2 times 2 times 2. Right? So if I want that to the 1/3 power, that just means I want 1/3 of those factors. Right? So there's 3 of these. 1/3 of those would just be one of them. Right? So this is the same thing as the cube root of 8, or the cube root of 2 times 2 times 2. Cube root of that is just 2. All right, I want you to pause and try to do these 3. 49 to the 1/2 power, 216 to the 1/3 power, 16 to the 1/4 power. Pause and simplify those. All right, let's see what you got. So 49 to the 1/2, that just means the square root of 49, which is 7. 216 to the 1/3 power, that just means the cube root of 216. Right, 216 we know is 6 times 6 times 6. Right, so the cube root of that, or just saying we want 1/3 of those factors, right, that would just be 6. 16 to the 1/4, what would that mean? Right, that means the 4th root of 16. Right, 16, if you do the factorization of that, that's 2 times 2 times 2 times 2. Right? So the 4th root of that, or saying I want 1/4 of those factors, that is just going to be 2. All right, so what if I have one that doesn't come out perfectly, like this one, 40 to the 1/3 power? Right? So that means the same thing as the cube root of 40. Right? And let's work this out. Let's do a factor tree on this. So what numbers multiply to get 40? That would be, let's see, 4 times 10 works. 4 is 2 times 2, and 10 is 2 times 5. Right? So what does this mean? This means that the cube root of 40 is the same thing as the cube root of 2 times the cube root of 2 times the cube root of 2 times the cube root of 5. Right? And right here, there's 3 of these factors of the cube root of 2. Right? And by definition, cube root of 2 times cube root of 2 times cube root of 2, that's the cube root, or that's just 2. So this would be 2 times the cube root of 5. That's the answer right there. Right? And I want you to realize that we could write that answer 2 different ways. that's one way to write it, 2 times the cube root of 5. The other way to write it would be like this, 2 times 5 to the 1/3 power, right? Because this is the same thing. Cube root of 5 is the same thing as saying 5 to the 1/3 power. All right, I want you to try these two on your own, right? So 240 to the 1/4 power, and then 12 to the 1/3 power times 28 to the 1/3 power, right? And I would like you at the very end to try to write your answer in the two different ways that we've talked about here. Right? Pause, please, and do these two. Let's see if you got the right answer. All right, so for number 8, this is the same thing as thinking about it like this. The 4th root of 240. All right, let's do a factor tree here. This would be 24 times 10. 10 is 5 times 2. 24 is 4 times 6. This is 2 times 2 for 4, and 6 is 3 times 2. All right, so this means this 4th root of 240 is the same thing as the 4th root of 2 times 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 the 4th root of 3 times the 4th root of 5. Right? And by definition, right here, 4th root of 2 times 4th root of 2 times 4th root of 2 times 4th root of 2, that is just 2. So this would be 2 times the 4th root of 15. And the other way to write that would be like this. 2 times 15 to the 1/4 power. Oops. Okay, sorry about that. Let's write that better. So 1/4 here. Okay, number 9. Let's see how you did on this one. All right, so let's realize that this is just saying the cube root of 12 times the cube root of 28. Right? And we could do a factor tree on this. This is 4 times 3. This is 2 times 2. All right, so that means that the cube root of 12 is just the same thing as saying the cube root of 2 times the cube root of 2 times the cube root of 3. Right? And if we do a factor tree on 28, well, that's just 4 times 7, and 4 is 2 times 2. So the cube root of 28 is just the cube root of 2 times the cube root of 2 times the cube root of 7, right? And in the original problem, right, we were just multiplying these two things, right? So these are just being multiplied. All right, so maybe I can rearrange these so it looks a little bit nicer. So this is the same thing as the cube root of 2 times the cube root of 2 times the cube root of 2 times we have another cube root of 2, cube root of 3, and cube root of 7. Right? By definition, what is this? Cube root of 2 times cube root of 2 times cube root of 2? That's just 2. And what do we have left over here? Cube root of 2 times cube root of 3 times cube root of 7. This is the cube root of 42. Right? And the other way to write that would be like this. 2 times 42 to the 1/3 power. Right? So both of those mean the same thing. Okay, last page here. I'll do number 10, and then you'll do number 11. All right? So think about what this means. 5 divided by 4 to the 1/3. Well, this means the same thing as 5 over the cube root of 4. Right? And what we'd like to do with this is we'd like to rationalize this. Right? If you haven't watched the previous video, make sure you go back and watch that, right? Because that will teach you how to do this. All right, but let's think about how we could rationalize this. How could we write this another way so that we don't have radicals in our denominator? Well, first thing I would do is realize that this is the same thing as 5 over the cube root of 2 times the cube root of 2. Right? Because 4, right, when I have a cube root of 4, that's just 2 factors of 2 there. Right? And what can I multiply this by so that I wouldn't have radicals in the denominator? I would need to multiply this by cube root of 2 over cube root of 2. Right? And so on the top, I would have 5 times the cube root of 2. On the bottom, cube root of 2 times cube root of 2 times cube root of 2, that's just 2. Okay? That's what we want. We want to have an expression that does not have a radical on the bottom. So we've got 5 times cube root of 2 over 2. And just as a reminder, the other way to write that answer would be like this. 5 times 2 to the 1/3 power over 2. Right? So both of these are the same thing. All right, finish this last one, and then you'll be done. Pause and finish it. All right, let's check. So this, again, this means the same thing as the cube root, no, sorry. Not cube root, let me erase this. I meant to say the fifth root. Fifth root of 3 divided by the fifth root of 8. Right? And the first thing I would do is I would simplify the bottom. Or not simplify, let's rewrite the bottom. Remember, 8 is the same thing as 2 times 2 times 2. So I could rewrite the bottom as fifth root of 2 times fifth root of 2 times fifth root of 2. Right? And now let's think, what do I need to multiply by so that I would not have radicals in the denominator? I need to multiply by 2 more fifth roots of 2 on top and 2 more fifth roots of 2 on the bottom. Right? Why is that? Because I want to have 5 fifth roots of 2 on the bottom. There were already 3 in the beginning. I need 2 more. Right? And when you multiply that out, right, the bottom part, that's just going to be 2. Right? Because fifth root of 2 times 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 fifth root of 2, that's just 2. Right? And on the top, we're going to get the fifth root of 3 times 2 is 6 times 2 is 12. Okay, so this is our answer right here. And if we want, we can write this the other way. This would be 12 to the 1/5 power over 2. All right? So both of these mean the same thing.